Hello. All right, and we're back. So, one-step equations with fractions and decimals. So it's time to crank it up a notch. Woo! So we're going to use what we've already learned about algebra and what we already know about fractions and decimals to solve and check the equations below. So our one-step equations are not always going to be so easy. Now what we've got here are decimals involved. So the process is still the same, but this is where those showing your work really comes in handy. So we always start by drawing our scale bar, and we want to get our x alone. So we want to isolate this x. So we do that with our inverse operation. So right now it's being subtracted by 4.4. So in order to get it alone, we have to add 4.4. Now this is where showing our work is really going to come in handy here. So if I add 4.4 to the left, I have to add 4.4 to the right. I draw my equals bar. This cancels out and leaves x by itself. And now remember, when we're adding decimals, we want to line up our decimals and then add from right to left. So 2 plus 4 is 6. I bring down my decimal. 7 plus 4 is 11. So x should be 11.6. And now what we can do is we can check our work. We start with our original equation, x minus 4.4 equals 7.2. We substitute in 11.6 for x, so 11.6 minus 4.4 should be the same as 7.2. And then we remember we're solving the left side independent of the right side. So 11.6, so 0.6 minus 0.4 is 0.2. 11 minus 4 is 7, and we get 7.2 is the same as 7.2. So we know we did this correctly. All right, go ahead and pause and try this problem. Now this one's a fraction, so it's going to be a little bit different, but the process is still the same. Okay, so to show our inverse operations correctly, we start with our scale bar. Now we have to get n by itself, and n has plus 1/3 attached. So we have to subtract 1/3 in order to cancel that out and to get n by itself. That was a sloppy line. So 1/3, and then so plus 1/3 minus 1/3 equals 0, which means that we know we get n by itself. Now if I subtract 1/3 on the right, I have to subtract, or on the left, I have to subtract it on the right. Now this is where those fractions come into play. So because we know we have to have a common denominator, I need to find that. So my common denominator is going to be 6. So 3 times 2 equals 6, so 1 times 2 equals 2. 2 times 3 equals 6, so 1 times 3 equals 3. And what I'm doing here is 3 minus 2, which is 1, and my denominator is 6. So n is the same as 1/6. Now to check my work, I use my original equation, n plus 1/3 equals 1/2. I substitute in 1/6 plus 1/3 should equal 1/2. And then now I need those common denominators. So I know 1/6 plus, if I multiply 3 by 2, I get 6. So 1 times 2 is 2, should equal 1/2. And 1 plus 2 is 3/6, which should be the same as 1/2. And I know if I simplify 3/6, I get 1/2. So this is a correct equation. Okay, a couple more practice problems here. Now this one is multiplication, so go ahead and pause your video and try this problem. Okay, so we start by drawing our scale bar. Now E, if I read this correctly, it's 1.3 times E equals 7.8. So I know that E is being multiplied by 1.3. So in order to get that alone, I have to do the inverse operation of multiplication, which is divide. So I'm actually dividing by 1.3 on both sides. So that cancels out here and leaves E by itself, but now I can't do 7.8 divided by 1.3 in my head, so I need to do some sardine work off to the side. So 7.8 goes inside the house, 1.3 goes outside. I know when I'm dividing decimals that my divisor needs to be a whole number, so I move my decimal place once and I raise my roof. Now, 13 goes into 78. Let's think here. I know 13 times 5 is 50, plus 15 is 75. So I'm going to start with 5 here. 5 times 3 is 15. 5 times 1 is 5, 6. So that's not right. So I'm going to go backwards here and I'm going to try a 6. 6 times 3 is 18. 6 times 1 is 6 plus 1 is 7. So I know that my answer, 7.8 divided by 1.3 is 6 even. So to check my work, I use my original equation, 1.3 times E equals 7.8, and I substitute in 6 for E. So 1.3 times 6 should be the same as 7.8. Again, if I need to double check this, I need to do scratch work off to the side. But I can kind of do this in my head. So 6 times 3 is 18, carry the 1. 6 times 1 is 6, plus 1 is 7. So I get 7.8 is the same as 7.8, so I did that correctly. All right, number 4 here is actually a division problem. So go ahead and pause now and try this one on your own. Okay, so I start with my scale bar. Now I notice that y is on the right side. So if I'm reading this correctly, it should be 1/3 is equal to y divided by 1/2. So something divided by a half equals 1/3. So I have to get y by itself. Right now, y is attached to divided by 1/2. So that means that in order to get this alone, I actually have to multiply it by a half. So if I'm multiplying by 1/2 on the right, I need to multiply by 1/2 on the left. I draw my scale bar. This cancels out and leaves y by itself. And then I know to multiply here, I do top times the bottom. So 1 times 1 is 1, 2 times 3 is 6. So y should equal 1/6. To check my work, I rewrite my original equation, 1/3 equals y divided by 1/2. And I substitute in 1/6 for y. Now I'm going to change the way I'm writing this just a little bit because it is fractions, and so it's harder with the fraction bar and fraction on top of a fraction. So I'm going to bring back the old school divide sign here, and I'm going to say 1/6 divided by 1/2. Now I know that in order to do this, I have to copy down the first one, change division to multiply, and flip the second fraction. And then I can actually cross simplify here. So 2 becomes 1, 6 becomes 3. And then I get 1 times 1 is 1, and 3 times 1 is 3. So 1/3 is the same as 1/3, so I know 1/6 is my correct solution. All right, so your homework today is going to be on Khan Academy. You will have some practice problems with decimals and fractions. Please make sure that we are showing our work correctly because it's going to be more difficult for us if we're just doing a bunch of random scratch work. So I want to see these inverse operations, getting your variable by itself or isolating your variable, creating an equivalent equation in order to find your solution.